Hi, Miss Neville Science students. Let's get into our next recorded lesson about the lever or lever. The lever is the second simple machine we're going to be learning about in our simple machines unit. Your learning objective for this lesson is to be able to construct a model that shows the most efficient class of lever. So today what we're going to be doing is learning about the lever, learning about where the effort force and resistance force is, and what parts of the lever make it so effective, and how can I reconstruct a lever to make it efficient or easy to use. Let's get to work. So when we're talking about our lever, it's important for us to know, please draw this picture in your notes, it's important for us to know that the lever has some very important parts. The straight board, there will be a straight board here, and this pivot point is called our fulcrum. Can you say that word for me? Fulcrum. The fulcrum is where the straight board will pivot. When Miss Neville's talking about pivoting, if this is my straight board and this is my pivot point, a pivot means to turn. Your elbow is a pivot, okay? Your elbow pivots or turns, okay? And so that's where that straight board of an arm, it pivots at the elbow. Our elbow is a fulcrum. Please take some time to draw this picture in your notes now. So as we move on and we're learning about the lever, we're now going to draw some pictures together today. I want you to, in your notes, and feel free to pause this screen, you'll want to draw each of these different classes of lever. So let's highlight. This is the first class lever in a different color. This is my second class lever. And in yet another color, this is our third class lever. And when you look at those pictures, what makes each of those classes different? The location of that fulcrum or the location of that pivot point. When we're looking at a lever, we can think of it like a seesaw. A seesaw is probably one of the most popular levers that we get to look at. So when we're drawing this in our notes today, we want to make sure that we have that straight board there and our fulcrum or our pivot point. We're going to label this as our fulcrum, just like you should have in that last picture. And when we're looking at our fulcrum, it's also important for us to know that a lever, just like an inclined plane, in order for it to be able to make work easier, it has to be lifting a load. So I'm going to put a box on this lever and label it my load. You want to make sure you understand that where I put my effort in, my effort is always going to be opposite of my load. It's going to be in the opposite place of my load. So my effort force, remember the abbreviation I'll use there, my effort force is when I push down to lift that box up, and my resistance force is the opposite invisible force acting against my effort force. Okay, and so when we're looking at this lever, this is a very simple seesaw lever. We see three different classes of lever, and so based on your learning objective today, we have to determine which of these classes of lever are the most efficient. Let's get to work. In order to do that, we're going to do a virtual lab together. In your notes, if you would please draw this chart. Be sure you write down your testable question, your hypothesis, and your conclusion. When you're working on your testable question, hypothesis, and conclusion, it's important for you to understand that up until this moment, or even right now, Miss Neville has shown you and given you your testable question. With our next virtual lab that we'll do with the pulley, you'll be forming your own hypothesis. Yes, you'll be forming your own testable question and your own conclusion. So today, go ahead and pause the video if you need to. I would like for you to write down in your notes at the top of your page, experimenting with the lever, or gizmo, and the testable question. The testable question is the question we're working to get an answer to. What question is our lab working to answer? So in this case, our testable question is, in which position does the fulcrum help the lever to be its most efficient? My hypothesis that I put down, you could put down a different hypothesis if you'd like. My hypothesis is my educated guess that answers my testable question. So my hypothesis is the lever is most efficient when the fulcrum is closest to the load and farthest from the load or in the middle of the board, okay? So in the middle of where my effort force and resistance force would be. So go ahead and write down your testable question. You're going to finish this sentence with one of these three choices, not all three. You're going to complete this sentence with one of these three choices. 1, 2, or 3. Okay. One of these is the answer. You have to choose which one you think it'll be. In other words, where will the fulcrum be that make the lever the most efficient? You then want to draw this chart. This is the chart that we'll use in class as we are completing our notes. And then you want to write your conclusion. And Ms. Neville started you off. Here, you're going to finish this sentence and be sure to choose at the end of our lab, you're going to tell me if your conclusion was correct or incorrect. Take some time, pause this video, and please draw this virtual lab report in your notes. You'll need it for class. Okay, so let's write this sentence down in our notes because we're going to find the answer to this question in class on Monday. The implications from our data. In other words, that's a lot of big words. In other words, what does this data tell us? So based on the data in that chart that we're going to be able to fill out, what does this data tell us? Okay? And we're going to write down the sentence. The lever is most efficient when the fulcrum is located where? We're going to be able to answer that question based on the data that we receive. Okay, so I hope you enjoyed this lesson today. We will see you in class on Monday. Bye, guys.